So with this Gibson J15, it's just a simple operation, just installing a couple of strap buttons. But I do find the single pivoting block with a single platform and the single strap really makes it easy when you're doing any operation, electronics, or this type of job, installing strap buttons, where you're flipping the guitar around and holding it on its edge. So without the use of vices, clamps, or any type of mechanical fixtures, I can hold the guitar safely and firmly in the best orientation to do this job. So I've installed this strap button and installed a strap button in the end of the guitar. Let me bring you in for a look. So the idea is to eliminate this as a strap button. So everybody knows that these things loosen up. Before I installed this strap button, I checked it, and sure enough, it was rattling loose. And here is a quick fix for that. Just wrap it in leather, grab it with the vice grips, and tighten it up. That's it. I can say with confidence, as long as Leighton owns this guitar, that will never come loose, because this is what he will use for his strap button from now on. For anyone who has worked on guitars for any length of time, they find out pretty quickly that this basic orientation is by far the most common when you're working on a guitar. When the guitar is in this position, I can work on the bridge, the frets, the nut, machine heads. This single block, oftentimes what I'll do, I'll tighten it down initially and then just back it off a little bit so that it is just loose enough to allow me to flip the guitar on its edge, and then I cinch it down. This is definitely one of the advantages of the XLT, is its versatility when sort of flipping guitars around. Even Strats and Tellies, I can flip them up on their edge and feed the strings through the back. If I'm changing machine heads, I'll lift that platform, and then I drop the neck platform, and that puts the headstock kind of in the center of my chest. When I'm switching out machine heads, that's the orientation I use. The other thing that I often use is to just be able to put like the guitar face down. The void between those splayed rails allows the strings and the bridge to be put face down. This new portable design with the TechDeck built into a case leaves, as you can see, tons of room for tools. So I use that high density foam, jam my tools into that so they're ready to snap up and go. And underneath the body platform, as you can see, I've got the snap shut containers, got a container full of potentiometers, wiring and input jacks, nuts and saddles, and then an assortment of screws and springs. Without exaggeration, I easily have over 250 different items and tools and parts, all stored within reach in 2.7 square feet. This trough on the end, I've got my bridge pin reamer and some more Allen keys just sort of jammed in to that high density foam. And I have my longest straight edge here, just on the side. Well, this Martin guitar with a split on the bass side from just past the waist almost right to the tail block is another good example of a guitar that needed to be flipped. As I got inside to place that plexiglass plate up against the sides, and then eventually put one string at a time into my little crack jigs that I've made. I'll give you more detail on these jigs that I use for pulling the sides flush, because this crack, it's not just that it's separated this way, but it shifted so it wasn't level. So these jigs that I've made up pull the two sides of the crack dead level as I clamp down. I'm just about to do that now. Mix up some hide glue. This will be done in multiple steps. But again, this guitar was flipped up on its edge, on its back, over the course of getting to this stage. I've got 4 of my little guitar crack winches. This is another one of those jobs that's much easier to explain. As I disassemble, I'll explain exactly what we did here. So that's the Lexan backer plate that I heated up with a hairdryer and bent and fitted into place to be able to use those string winches to ensure that both sides of the crack were flush. Many of you have been listening to me sort of extol the virtues of hide glue. This is one of them. It doesn't stick to lacquer. There's no other glue that you could get away with this. So I whipped that hide glue into that crack, made sure that it was good and saturated. I didn't really have to be concerned about the outside because it's going to be touched up anyway, but as you can see, the hide glue doesn't stick to lacquer. Okay, I just wanted to quickly show you that. It just kind of flakes right off. I'm using my sharpened tongue depressor as a soft knife edge to sort of clean that up. Anyway, we're going to get back to this later because we still need to put all the cleats in along this crack. We're not done yet. So I've got an old soundboard here and I cut out 10 circular cleats with my plug cutter, and then I thinned them out, just held them with one finger on the radius disc sander. So now we'll mix up some more hide glue for these 10 cleats and we'll follow that fault line of the crack. Well, we got that crack sealed up pretty good. I'm happy with that. I have this circular patch that I put on. So I'm going to pull that magnet off and then we're going to back up for a second and I will explain precisely how I got to this stage. We have 7 circular quarter sawn patches along that fault line. So that's how I affix the patch to the magnet. That's how we glue that centered on the fault line. So now that I've got that centered on the magnet, I can put a little dab of hot hide glue on there. So with the magnetism guiding me, I hold this magnet over the fault line and reach in with my mangled palette knife and let the magnetism guide the patch into place. So this magnet is held dead center on the crack, and this one is fed in through the sound hole with a little dab of hot hide glue on there, and that way I know I'm centered. That's our last patch, so now I can reconnect the input jack and the battery cable that I had to disconnect in order to do this job. So the battery and the end pin jack for this system has been reinstalled. I've just got to put the cable ties back on the inside and rub it out, and we should be good to go. Welcome back, everyone. Saturday morning. As I wrap up that Martin guitar of Fred's with a huge crack that we repaired, I thought I'd take a minute to sort of go through the design of these jigs that I use. So as you can see, it's a machine head. I have a couple of dowels in there, and I've put, you know, those little screws that you get for holding the machine head down. I installed those in the ends of the dowel, so this way it opens up just enough to get that string through. You saw them on the guitar, but I thought I would take a minute and explain. Like, this is, as you can see, sort of a concave shape. This is also concave. So this is one of the crack winches that you saw me use on that job, and you can see that it has a concave form that spreads along the length of the crack. That's what pulled that portion together flush. You can see that this doesn't have a curvature, it's basically straight. This one has a slight curvature, less than these two. So those two dowels allow the blocks to spread so you can get the string in there. Once you get the string in, you can kind of close it up a little bit. The nice thing about this, and especially that repair that I just did, I really needed to saturate that entire joint. You got about 80-85 thou of thickness of that rosewood on either side of that crack. So that's not a lot of gluing surface, and you'll notice that even after taking these jigs off, I left those quick grip clamps on until I had glued in a few of those circular cleats to hold that crack. So as you can see, it's kind of a step-by-step process. But we are definitely on the home stretch now. Let's get back to the guitar for a second. This is what we ended up with. I am just going to flip that up on its edge, and we got enough lacquer left on that rosewood. I should be able to just rub this out. So I can live with that. Is it perfect? Is it flawless? Can it be detected? Well, it certainly can for someone who knows the crack was there, and if you put on a jeweler's loop and look at it, when you think of the gaping crack that was there at the beginning of this video, it's come a long way. So we're gonna go with that. Very happy with the result. So the other thing about the sort of orientation of the guitar while you're working on it, I like the fact that the whole thing is elevated for eyeing the neck. The sight lines are awesome. We've got the perfect amount of relief in this neck for filing out the nut, for doing all the final tweaks on the nut, for the height adjustment, and for the values for the intonated nut. And this has got one of those, the plastic or whatever it is that Martin used instead of ebony. And I got to admit, the reaction to the neck under string load and the truss rod itself are both working beautifully with this ebonite, or whatever it's called. I did not glue the nut in because we need to do a light fret dress. Fred has logged in some serious time on this guitar. You can see by the fret wear. Just stick that tongue depressor into there to pull those strings out of the way. And when I'm doing a quick fret dress like this, there's a little trick to kind of get those strings to pull out of the way as we do our work. I will be putting a new set of strings on. When you have a preamp that has exposed open circuit electronics, you don't want to get steel wool filings in there. So masking off the sound hole like 100% becomes even more important. So there's no need to use a leveling file in this instance. We will just use the scrub block, and we will scrub out with those minute marks in the first 8 frets or so. So this is the 400 grit, and as you can see, the guitar is actually held by the body. Fretboard access is wide open for me to edge dress. I don't need to in this case, but to edge dress or fret dress, or do any type of fret work without any clamps or vices getting in the way of my work. It's wide open. Not only is it wide open, but this orientation lets me see exactly what I'm doing and the job as it progresses. So here's our first use of the scrub block with the 400 grit to just get rid of those minute marks in the first, like I said, 8 frets or so. There isn't enough wear to warrant pulling the frets. Here's my 600 grit. I'm sure even the camera picks up the sonic difference between 400 and 600. You can hear the sound change with the lighter grit. Now, all traces of string wear are completely gone. I much prefer to have the instrument elevated a little bit, so I'm not kind of hunched over all day. Anyone who's done an 8-hour day working on guitars understands exactly what I mean. Final buff with a jeweler's rouge. Okay, we quickly get rid of any trace of compound. A little dab of lemon oil, wipe it on, wipe it off. I mean, it isn't wood, so it's not like it needs to be oiled, but you know, it just cleans it up, makes it look nice. It makes some people think that it might actually be wood. You know, I have to admit that, you know, it is responsible of Martin to design a product that takes the place of the endangered species ebony. You know, it performs the task. Well, you can see that there is a respectable amount of wear on this guitar. There are a few sort of nicks and scrapes and knocks and bumps, and that's kind of typical for a guitar that is actually played. Fred logged in some pretty serious playing time on this guitar. You can see the typical wear on the edge of the sound hole. But overall, the guitar's in pretty good shape. And now that that gaping crack is taken care of, this guitar will be good for a long time to come. So here is the finished compensated cantilevered bridge saddle. And of course, this is 12 to 53 at concert pitch. And there is a final peak at the compensated nut as well. So this is just straight acoustic, straight up. Electric system here. so I've looped this A major thing.